Welcome to Brain Vision.
All right, this problem is a combination of two different things, both gas laws and stoichiometry. The first thing I'm going to do is write out the balanced chemical equation. We have chlorine gas plus fluorine gas. They're both diatomic, producing chlorine trifluoride. This needs to be balanced in order to complete the problem, so we'll go ahead and do that now. The chlorines are not balanced. We have two on the reactant side, one on the product side. I can fix that. That then changes my fluorines to 6. So I need a 3 in front of the F2. And then I'm good. Now, information that they gave us in this problem are that the chlorine has a partial pressure of 337 millimeters of mercury, and the F2 has a partial pressure of 729 millimeters of mercury. Now, when we're dealing with gas laws, we can assume that these partial pressures are the total pressure for that compound in the mixture, and that that gas takes up the entire reaction vessel. It's one of the assumptions that we make when we deal with gas laws. So I need to find number of moles, which means I'm going to have to use PV equals nRT. I'm going to convert these pressures into atmospheres because that's what I prefer to use, and that R is the one that I have memorized. So we're going to go ahead and convert both of these millimeters of mercury into atmospheres. I'm going to start with chlorine, so I have 337 millimeters of mercury. We're going to multiply that by 1 atmosphere over 760. This gives me 0.443 atmospheres. Once I have that, I can plug into the rearranged version of this formula. I need to solve for moles, which is going to equal PV over RT. So the pressure that I have is 0.443 atmospheres. The volume, this is taking up 2 liters. That's the reaction vessel that this is in. My R is 0.0821. The unit for that is liters, atmospheres per mole K. Very annoying unit. And then we're going to also be dividing here by 298 Kelvin. So plugging that in, we are going to get 0.0362 moles of Cl2. Now, I want to know which one's the limiting reactant, so I'm going to go ahead and convert this into moles of ClF3. And here we're using the balanced equation to do that. 2 moles of ClF3 over 1 mole of Cl2. This gives me 0.0724 moles of ClF3. This is not done yet. That's the first half of it. I need the values for the fluorine gas so that I can compare them. So again, I am converting my 729 millimeters of mercury into atmospheres. That gives me 0.959. And then I'm going to plug in the only number that changes from when I plugged into PV equals nRT on the top is the first value. So 0.959 atmospheres. It's still in the same vessel, which is 2 liters. The R does not change. That's the gas constant. And the temperature didn't change. That was 298 Kelvin. So here I get 0.0784 moles of fluorine gas. I'm going to use that balanced equation again. For every 2 moles of ClF3 that I made, I am going to use 3 moles of F2. So when I do this math, I get 0.0523 moles of ClF3. Now, what do these numbers tell me? If the Cl2 was the limiting reagent, I could make 0.0724 moles of product. But I can't make 0.0724 moles of the ClF3 because over here I can only make 0.0523 moles of it because I'm running out of the fluorine gas. This number is smaller, which means my F2 is my limiting reagent. Now, the other part of this question is it wants the mass that we could make, or the theoretical yield. So I'm going to take my moles of ClF3 and multiply it by its molar mass, which is 127.90 grams. And that is going to give me 6.69 grams of ClF3 as my theoretical yield. So this is your final answer, along with the fact that F2 is limiting.